In previous videos, we have discussed how to organize the data for discrete distributions, especially discrete probability distributions, into the table format as well as graphically represent it. In this video, what we're going to do is we're going to learn how to find the mean, the variance, and the standard deviation for these distributions. So the first one that we're going to look at is the mean of the distribution, especially the discrete distributions. And what this formula looks like is we're going to take each possible outcome and multiply it by its corresponding probability. Then I'll add each of those up. So I take the first possible outcome times its probability, plus the second possible outcome times its probability, and so forth until I get to the last possible outcome multiplied by its probability. This will give me the mean. This is another way of looking at the formula, and remember that this symbol right here just means sum, or to add everything up. Add up all of the possible outcomes times their probabilities. As I said, what we're doing is x1, x2, x3, all the way up through x sub n are our possible outcomes. Think about rolling the die and what our possible outcomes are there. We have 1, 2, 3, 4, 5, and 6. So those would be like our x1, x2, x3, and so forth. The probability of x sub 1, probability of x sub 2, probability of x sub 3, all the way up through the probability of x sub n. Those are the corresponding probabilities. So let's look at how we can find the actual mean. Let's use our rolling of a die problem. So our possible outcomes for rolling a die are going to be 1 through 6. So 1, 2, 3, 4, 5, and 6. And their probabilities are all 1/6. Hopefully we can agree on this. Therefore, the mean of this is going to be 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. So then I multiply these out, and I get that the mean is 3.5. So 3 and 5/10. For the mean, the variance, standard deviation of probability distributions, we are still using the same rounding rule. They must still be rounded to one more decimal place than our original data or our possible outcomes. So in this case, our possible outcomes were whole numbers, so my mean should be one decimal place. Let's look at the example where we were discussing the DVD rentals prior. So here we have the number of DVDs rented, 0, 1, 2, 3, and 4, and we have their probabilities, 1500ths, 2500ths, 3/10ths, 2500ths, and 500ths. And we want to find the mean of this distribution. One way of finding the mean is also to add on a row here that just takes x times its probability. What I'm doing is taking the possible outcome and multiplying it by its probability, which is the same thing that we do in our mean formula. Because doing the mean formula, I would take 0 times its probability plus 1 times its probability plus 2 times its probability plus 3 times its probability plus 4 times its probability. And if I fill in my row, I get that 0 times 15 hundredths is 0, 1 times 25 hundredths is 25 hundredths, 2 times 3 tenths is 6 tenths, 3 times 25 hundredths is 75 hundredths, and 4 times 5 hundredths is 2 tenths. An easy way to find my mean is to add those up and I have my mean. Or I can write out the formula and I can get the exact same thing down here. Each person is going to choose their own way of doing this. It is completely up to you whether you want to tack on extra rows to the table or if you want to do out the formula. It does not make a difference. Therefore, the mean number of DVDs rented is 1.8. Okay. Well, let's look at variance and standard deviation. For variance, remember we're using sigma squared. What we're going to do here is we're going to square each possible outcome. So like with our rolling of the die, we would take 1 squared, then multiply it by its probability, plus 2 squared, then multiply it by its probability, and so forth. But at the very end, we must subtract out the mean squared. This is very important. To get the variance, we have to subtract out the mean squared. Therefore, we have to make sure that we find the mean first. Standard deviation, we do the exact same process because remember that standard deviation is just the square root of our variance. So let's look at our example with DVD rentals. We want to find the variance and the standard deviation. And so usually whenever I start with a problem like this, I have my table and I add on one row for helping find with the mean. That is my x times my probability of x. And whenever I add all those up, that's going to equal my mean. Usually I just tack on another row here, and I take this as being x squared times the probability of x. It's the same thing as taking my previous row, which was my x times probability of x, and multiplying it by x again. Gives me the exact same answer. Okay? I will need to add up this row. Unfortunately, this does not give me the variance. I'll have to do a little bit of manipulation, but I can at least fill in these items. 0 times 15 hundredths is 0. 1 times 25 hundredths is 25 hundredths. 2 times 3 tenths is 6 tenths. 3 times 25 hundredths is 75 hundredths. 4 times 5 hundredths is 2 tenths. Then I can either take 0 times 0 and multiply it by 15 hundredths, which gives me a 0. 1 times 1 is 1 times 25 hundredths gives me 25 hundredths. 2 times 2 is 4 times 3 tenths will give me 1.2. 3 times 3 is 9 times 25 hundredths will give me 2.25. 4 times 4 is 16 times 5 hundredths will give me 0.8. Now if I add these up, my mean, like we found previously, was 1.8. Now if I take that last row and add it up, I will get 4.5. And my variance is going to be 4.5 minus my 1.8 squared. That's the key, is I have to square the mean. I can't just subtract those two numbers, I actually have to square the mean. So I get 4.5 minus 3.24. So my variance is 1.26, but remember our rounding rule. I have to round it to one place more than my possible outcomes. They're whole numbers, so I can only have one decimal place here. So my variance becomes 1.3. This would give me the exact same thing if I were to write out the problem. If longhand, I would take 0 squared times its probability plus 1 squared times its probability plus 2 squared. Let me rewrite that because I accidentally erased all of it. So 1 squared times its probability plus 2 squared times its probability plus 3 squared times its probability plus 4 squared times its probability minus my mean squared. So notice I'm still subtracting out the mean squared. So I get 0 squared, which is 0, times 0.15, still 0. And I'm going to get these same numbers that I did previously in that last row that I added on. 1.8 squared was the 3.24. So whenever I do all that addition, I get 4.5. Then I need to subtract out the 3.24. So my variance is still 1.26, but whenever I round that properly, I get 1.3. Again, it's the exact same number done two different ways, does not matter. These are our variances. We still need our standard deviations. The standard deviation is the square root of our variance. So we take the square root of 1.3 and we get that is 1.14. Again, rounded properly, that becomes 1.1. And let me make that correct. 1.1. So my variance and my standard deviation for the DVD rentals. Remember from previous, standard deviation and variance take quite a while for anything that we're looking at. You'll just have to kind of play with it a little bit and do some practicing. There's one more thing that we look at when we're in this area, and that is expected value. Expected value is used in games of chance and in insurance. And what I mean by that is it's used in what is the expectation of the outcome of a game. Are you expected to win or are you expected to lose? Insurance policies are done up this way. Are you expected to be a hazard? Are you high risk? Insurance companies want to know that, and so they use expected value to figure that out. It's also considered a theoretical average because obviously we don't know the exact average of these things. It's all a chance. We don't have a clue of what is actually going to happen. Expected value is denoted by E of x, expected value of this outcome. It is the exact same thing as your mean for probability distributions. And that is why I have that here in the formula. So it's the exact same thing as the mean that we've already been figuring out. We do have to be careful though when we're talking about expected value, because we always want to make sure that we're looking at the gain and the possibility of a loss. Remember, when we're doing discrete probability distributions, we have to make sure that our probabilities all add up to 1. So we have to look at, okay, do our probabilities all add up to 1, or do we need to add something in there? Let's look at an example to see what I'm talking about. Here's an example of a lottery that offers one $5,000 prize, one $1,000 prize, two $500 prizes, and five $50 prizes. 1,000 tickets are sold at $5 each. Find the expected value of this lottery if a person buys one ticket. When you're talking about lotteries or insurance for expected value, you want to set up a table. And that table is going to look something like this. You want the prize amount or the original amount of the policy. Then you want to know how much are you going to gain or how much are you going to lose. Again, you always have to look at the possibility of losing. Then you look at the probability of that happening. So let's set up this probability distribution. When we look at this, a lottery offers one $5,000 prize. So we have a prize amount of $5,000. We have one $1,000 prize. So we have a prize amount of $1,000. We have two $500 prizes. So we have a prize amount of $500. Then we have five $50 prizes. So we have a prize amount of $50. We also have the possibility of not winning at all. Therefore, we have a prize amount of 0. And this is what I mean by you always have to look at that loss column. Make sure you add in that loss column. But in this game, it's not free to play this game. You have to think about how much did it cost us to play. It cost $5 to play. Okay? Right here it tells us $5 to play. So what we're doing is we're going to take our prize amount and see how much we actually won. If we pay $5 and we win that $5,000 prize, we didn't actually win $5,000. We won $5,000 minus how much we paid. Therefore, here, your gain-loss column is your prize minus how much you have to pay. It's always your prize minus your payment. So 5,000 minus $5 leaves me with a gain of $4,995 that I'm actually going to gain when I get this. For the $1,000 prize, I'm going to take $1,000 and subtract off the $5. So 1,000 minus 5 leaves me with $995 that I actually win or gain. Going to do the same thing with the $500. I actually only gain or win $495. Then $50 that I'm going to win, I actually only get to keep or gain $45. Look at that last column, the loss column. I don't win anything, but I had to pay $5. So how much do I gain? I actually gain a negative $5. That's not very good, but you always have to do that possibility, okay? Now then, the probability row is number of prizes divided by the tickets. So how many $5,000 prizes were there? There was one $5,000 prize. And how many were sold? Well, there was 1,000 tickets sold. So that is the probability of getting that $5,000 prize. Do the same thing for the $1,000 prize. There's one prize out of the $1,000 tickets sold. Now, out of the $500 prizes, there was actually 2 of those out of 1,000. Out of the $50 prizes, there was 5 of those out of the 1,000. So far, if you look at this, I have 5, 6, 7, 8, 9 prizes, 9 tickets that are winners out of 1,000. So how many losing tickets do I have? My losing tickets are 1,000 minus the winners. So 1,000 minus the 9. So there are 991 losing tickets. So let me do that in the same color that I've been doing. 991 losing tickets out of the 1,000. And this is how you're actually going to find your table. Once you do this, we kind of ignore this row because here is your x and here is your probability of x that we're looking at to find our mean. So what we do is to find the expected value is we take how much we gain, which is 4,995, times its probability, 1 out of 1,000, plus 995 times its probability, 1 out of 1,000, plus 495, and looks like I need to scoot this all over because I'm going to run out of room. So let me try this again. Expected value is going to be 495 times 1 over 1,000 plus 995 times 1 over 1,000 plus 495 times 2 out of 1,000 plus 45 times 5 out of 1,000. Now since I'm going to lose $5, I'm going to say minus $5, and let me try to get that a little bit better, times 991 out of 1,000. And then we do the actual math for this to get the expected value. So our expected value, if I do the multiplication, I get 4.995 plus 0.995 plus 0.99 plus 0.225 minus 4.955. When I do all the addition and subtraction here, I get $2.25. With expected value, we don't do the same rounding. We have to look at what we're talking about, and we're talking about money here. So for money, we're actually going to round to 2 decimal places. So if a person buys 1 ticket, they are expected to win $2.25 on average. That might seem pretty good to some people, which it actually is. One thing about expected value, you can end up with negatives because some games are expected to have a loss, which is fine. Don't panic if you get a negative value right here. That is perfectly valid. You can expect to lose on some games. And it just means instead of expected to win, you're going to be expected to lose if you get a negative here. Try some of these for the mean, variance, standard deviation of the probability distributions. Also try some expected values, and let me know if you have any questions.